All right, in this video, I'm going to show you how to find the domain of a composite function f of g of x. So in this case, let f of x equal x squared minus 2 and g of x equal square root of x. I want to find the domain of f of g of x. So first off, I'm going to find the function f of g of x in its simplified form. To do that, I will take the square root of x and plug it into that x as I showed you in the last video. So I have the square root of x squared minus 2, and that's equal to x minus 2, since the square root of x squared is just x. All right, next I'm going to mark off the domain of this simplified version of f of g on a number line. So here's my number line, here's 0, and I can plug any value of x I want into x minus 2. So the domain of this simplified version is all real numbers. All right, next, I can't ignore the fact that in order to come up with this function, I started off with this one, g of x. So in order for x to be in the domain of the composite function, it not only has to work for the simplified version, it has to work for your original input function. So after I put down the domain of the simplified version, I've got to throw out all of the values of x that don't work for the original. Okay, so for the original, since I'm taking, for the original input, since I'm taking the square root of x, I know that x has to be greater than or equal to 0 because I cannot take the square root of a negative number. So here, for all these values of x that I got from looking at the simplified version, I now have to throw out everything that can't be plugged into here. So I have to throw out all negative numbers. So none of those guys are in the domain. I'm going to start at 0 because 0 is allowed for this, and everything above 0. Therefore, the domain of f of g of x in this problem is from 0 to infinity, or in interval notation, 0, infinity. All right, I'm going to recap that strategy for you. Okay, so the strategy is to first find the simplified form of f of g of x. Then you're going to mark its domain on a number line. Then you're going to throw out all of the values that are not in the domain of the original input function, g of x. All right, so I'm going to have you work on another example. Okay, so the example I'm going to do now is find the domain of f of g of x if f of x is 1 over x minus 4 and g of x is 1 over x. Why don't you press pause while you work on this example? Okay, first we're going to find f of g of x and then simplify it. So we take 1 over x and substitute in for that x. So we have 1 over x minus 4. To simplify this, I'd like to get this x out of the denominator. So I'm going to go ahead and multiply this by x divided by x. So then I have 1 times x in the numerator, or just x. X times 1 over x is 1, minus x times 4 is 4x. So f of g of x is x divided by 1 minus 4x. Okay, now I'm going to mark the domain of this on a number line. So as long as 1 minus 4x is not 0, any value of x can be plugged in. So if we set 1 minus 4x equal to 0, we get 1 is equal to 4x. So 1/4 is equal to x. So if x is equal to 1/4, it makes this denominator 0, but all other values of x are okay. So I'm going to go to 1/4, and I'm going to put an open circle there to denote that it's not included, but then everything else is fine. Next, I go to the input function, g of x equals 1 over x, and I find out what makes this denominator 0, because whatever makes this denominator 0 is not going to be in the domain of this, and therefore it's not going to be in the domain of f of g of x. So here we see that we have to throw out x equals 0 because that makes the denominator 0. So I'm going to go to 0, and instead of having it be having the line go through, I'm going to put an open circle to tell me that 0 is not allowed. Okay, so everything but 1/4 and 0 is just fine to plug into f of g of x, and so that's what the domain is. So -infinity up to 0, and then we don't include 0. Then union, we pick up at 0, then that goes to 1/4, and we have open at 1/4 because it's not allowed, and then we pick up at 1/4 and go to infinity. So union 1/4 to infinity. So this right here is the domain of f of g of x when f is 1 over x minus 4 and g is 1 over x.